Looking at the future of the world, what we're trying to do is tie together technology and humans in a way that they can actually collaborate, communicate, and partnership as far as how we're going to bring about the balance of business, environment, and community development. And we need all the assets that we have to do this as we move through the 21st century. And I have someone that's going to be coming on and talking about this human-machine partnership, which is a very intriguing idea and something that's coming into the fore as far as discussion and open society, but not many people know much about it. This is Dr. Brenda Bannan. She is the Associate Professor, Instructional Technology, the College of Education and Human Development at George Mason University. Also, she's the co-director of the Center for Human-Machine Partnerships. And Brenda, welcome to the EmeraldPlanet TV.
Thank you, Sam. Thanks so much.
We're glad to have you, and tell us about this center. I mean, this is something that's very intriguing. You don't really hear much about humans and machines collaborating, yet we see it in sci-fi. It's been in the movies, since the talkies, actually, black and white film. So why is this now becoming a major area of study at George Mason University?
Well, human-machine partnerships is a new and transdisciplinary research field, and it relates to how to structure and optimize the relationship between humans and computational systems. And the Center for Advancing Human-Machine Partnerships, that we call CAHMP with an H, that I co-lead with Dr. David Latanzi from Civil Engineering and Dr. Amarta Shihu from the Computer Science Department, really tries to examine that relationship and conduct research with different types of computational systems that partner with human beings in different types of settings.
Yeah, we're going to be talking about how that relates to first responders of all types. But it's really interesting that you have this human-machine partnership, but you're really focusing, as far as the initial studies anyway, on first responders. Why first responders?
Well, that's right, Sam. I've been working with first responder training, particularly live simulation training contexts for the last several years. We've worked in different types of hospital environments, in fire and rescue environments, and just most recently in active violence incidents or active shooter simulated environments. And these are very, very interesting types of complex, dynamic human systems environments. So the computational systems that we decided to try out in a human-machine type of partnership with first responders involve sensors, wearable sensors, and in-building sensors that would basically collect and feed us different types of data in real time during those first responder live simulation training exercises. And the data from those exercises, we tried to show kind of like an instant replay back to the first responders so that the mobile behavioral analytics that they would basically view and visualize could help their learning process.
Now, looking at this as far as strategic goals, they're talking about humans and machines, looking at the dynamically learning from each other, and then building trust and ethical conduct. Now, how do you do that in machines, and how do humans have the respect or the ways to honor a machine that says this is somebody or something that can be trusted and will actually deal in ethical conduct?
Well, the way we do it is through thinking about human-centered design or a co-design relationship with the first responders. So they help us define from the very beginning what are the most important metrics, how the computational system might be able to help them in their process. And they help us by actually reviewing it, trying it out, giving us feedback, and testing it. So they are involved all along in a human-centered design process. So that is how we begin to sort of address the ethics of what is most important to the audience who will be using that system. And along the way, that engenders trust, because the first responders then have a better understanding of what this computational system is doing, whether it's a sensor-based system or a robotic system, because they are co-designers of the system with us.
Now, looking at this, I guess this word spaghetti and all this that we're talking about, how do you sort through all of this and make sure that there's a balance between the humans and the machines? Or is this something that actually evolves over time so that the machine literally is learning about the humans are learning about the machine, and then they try to collaborate to come up with a unified policy or a unified response, or a way that actually first responders can handle situations that are very stressful, but also quite dynamic?
Right, so that dynamic and evolving and adaptivity between the humans and the machines is really the type of interaction that we are most interested in. And so being able to try out things and look at this design from many different perspectives. We have faculty members who work together from machine learning, from artificial intelligence, from learning sciences, from humanities, from public policy, in ethics, and having different viewpoints on these types of systems throughout the research process and the R&D process really helps us to be sensitized to what is really a perspective that needs to happen, that there needs to be trust, there needs to be transparency, there needs to be authenticity to the activity that's going on, and really examining that interaction between the humans and the system and working through that iteratively so that we all can understand what the technology system is doing, how it's informing the human system, and then reciprocally how the human system may be reinforming the technology system. So in that way, it's reciprocal and can engender trust if there are multiple perspectives and multiple inputs and insights into the building of this system.
So when you're looking at this interactive system that we have right in front of us, it's quite complex, but yet still very straightforward. But how do you have humans that are sensitized so they actually look at this machine as really being helpful to them, not just as a tool, as you have a hammer or a saw or a steering wheel in a truck or something like that, but it goes way beyond that, where this machine may actually save your life, help you to save the lives of others, and at the same time to make you more comfortable and more empowered to do your work. How do you do that in this type of what we would say is kind of a closed loop system?
Well, we do it in an iterative process where we try things out, and some things work and some things don't, and we get feedback and we try it again. And so the first responders are really trying to see a common operating picture or a common frame of reference in when they walk into an emergency situation, for example, or their leadership is really, there may be fire and police all and EMS all in one situation. And having a common operating picture and being able to all be on the same page and operating with the same types of data sources that are visualized in the best way possible might allow for an enhanced emergency response, meaning might drop the response time or save someone's life by being able to understand the building or understand where the first responder teams are, understand in real time where the victims are. So these are the types of things that the first responders can actually have a common operating picture and view through visualization. And that view can help engender some trust and being able to see the common picture across the leadership in order to make better decisions.
Mm-hmm. Now, let's look at this point here: teamwork, collaboration, co-adaptation, mutual trust. Building that trust. How do you go about doing that when humans are saying, "Well, we created the machines. Of course, we're going to be better than the machines are going to be," and at the same time, there are things that we can actually learn from the machines that really goes beyond just the creative process.
Mm-hmm. Yeah, well, it is human-centric in that humans can override machines, and humans actually can lead and should lead. However, humans need to understand what the computational system is and how it works, and the assumptions that are made with it. But if that is actually paid attention to through the process, it ends up being a more trusted system. So with humans and robotics, for example, there are many different types of data that can be collected by computational system, large amounts of data that can do what humans can't do, is process large amounts of data in a short amount of time, in a very quick turnaround. Yet humans looking at that data, they really need to be the ones who make the decisions and be able to override decisions and monitor decision making. So let the computational systems do what they're good at, let the human systems do what they're good at with higher level critical thinking. But more informed information can help first responders, particularly with more data that's given to them in an understandable way. And that's really the hardest part.
Yeah. And the whole thing about it is that at the end of the day, everybody wants to go home. And the ones that are being victimized or facing a natural disaster or human-made disaster, whatever it is, everybody wants to go home at the end of the day. So looking at this, and we're just about out of time, how do everybody, as we see here, getting ready to go into a very dangerous situation, the interaction between humans and machines, how does everyone go home, including the machine?
Yeah, that's a very interesting question. Well, the photo you're looking at right now was a live simulation training active shooter exercise.
Quick. We're running out of time.
In our Eagle Bank arena. And the way that we think people can go home and systems can actually be preserved is to be able to allow first responders to familiarize themselves with these types of technologies and help have input so that they can learn and adapt and get used to seeing different forms of information that could help them first in the simulation arena, and then eventually in the operational environment.
That's absolutely fantastic. We're going to go out on this. This is Dr. Brenda Bannan from George Mason University on the Center for Human Machine Partnerships. Thank you for being with us as we create the Emerald Planet.